Good morning, children. In class 10th, chapter 14, sources of energy, we are going to discuss today class. In class 10th science, especially for physics part, we are having 5 lessons are there. Electric effects of current, magnetic effects of current, light, human eye and wonderful world. This is a 5th chapter. It is not only the concept of physics, it is mixing of chemistry, biology also there. The sources of energy having only theory, which is very much useful for in our daily life. So daily life, especially sunlight, heat from the sun, we are utilizing a lot. The sun is one of the ultimate sources of energy which is giving heat and light. So the application of the sun energy we are discussing the chapter. So in the chapter, very important point for you which is useful for you, no typical numericals, no typical formulas and derivations are not there, only theoretical portions are there. So little bit you are doing hard work to memorize this all concept. Very easily we can get good marks from this lesson. We will proceed in this chapter. So in this lesson, mainly we are going to discuss the two important sources of energy. One is renewable, another one is non-renewable source of energy. And the example for renewable that we are calling as a non-conventional source of energy, solar energy, energy from the sea, geothermal and nuclear energy. Similarly, we have to discuss about non-renewable source of energy means conventional source. Fossil fuels, thermal power plant, hydropower plant, biomass and wind energy. These all concepts we are going to discuss in this lesson, that is sources of energy. So first of all, in our daily life, we are using a lot of fuels. In kitchen, LPG, liquid petroleum gas we are using. While traveling outside by car or two-wheeler, we are using petrol and diesel. This all is a sort of fuel. So before discovering or making one important fuel, what are the important points or characteristics we have to keep in our mind before constructing, before discovering. So the characteristics of a good sources of an ideal fuels are: one is you should have high energy output per unit mass or high energy output per unit volume. Means high efficiency. You should produce high efficiency. Second one, it should be easily available. It should be easy to store and transport. It should be economical. So these are the important 4 points. We have to remember it before getting a new fuel. This chapter, that is sources of energy, having main 2 important sources. One is conventional, another one is non-conventional source of energy. The another name of conventional is non-renewable sources of energy. Another name of non-conventional sources of energy is renewable source of energy. Okay, first conventional source of energy, that is non-renewable. What is mean by? This type of sources of energy, they do not renew or regenerate and are exhaustible. Once we are using means will not get back again. Second one, high cost operation. And third one, they produce a lot of pollutants. While using such a type of energy, the pollutions are producing in environment. The example for conventional source of energies are wood, fossil fuels. Example for fossil fuels, coal, petroleum and natural gas it is there. Second one, renewable or non-conventional source of energy. What is non-conventional source of energy? They are constantly supplied by nature and inexhaustible. This type of energy we are getting from the nature, especially sun. So sun energy continuously several million years we are using. So it is inexhaustible, low cost of operation, free of cost. Water energy and sun energies are free of cost. They produced little or no pollutants in environment. Examples of non-conventional source of energy are solar energy, wind energy, biomass energy, ocean energy, geothermal and nuclear energy. Some sources of energy are renewable like sun, wind, flowing water, ocean, biomass. Some sources of energy are non-renewable like coal, petroleum and natural gas. Okay. Now, under the conventional source of energy, just now we have discussed about what are the examples. Especially fossil fuels are there. So, what is the importance? What is the uses and the disadvantages? That we will see. What is mean by fossil fuels? They are fuels formed inside the earth from the remaining of plants and animals after millions of years. The fossil fuels are coal, petroleum, natural gas. Fossil fuels are non-renewable sources of energy. So they should conserve and used judiciously. What is the use of fossil fuels? We can see in our daily life. Petrol we are using everywhere for our transport. Natural gas also we are using. Coal we are using for generating electricity in thermal power plant. So advantages are there. At the same time, lot of disadvantages also there from fossil fuels. Burning of fossil fuels release gases and harmful particles which causes air pollution. Burning of fossil fuels release acidic oxides of sulfur and nitrogen which causes acid rain which is harmful for living organisms, affects soil and water, causes damage of buildings, corrosion of metals, etc. Third disadvantage is burning of fossil fuels release a large amount of carbon dioxide which increases the temperature of the atmosphere and causes global warming which is greenhouse effect. It will affect the greenhouse effect. Now I am showing some of the examples for such a type of disadvantages. So because of acid rain, the marble of Taj Mahal it's going to spoil. The people are so found this one it is there because of acid rain. Global warming, all ice are melted in the polar regions. So producing lot of water it is there. Then ultraviolet radiation is entering. Then greenhouse effect also affecting, trapping the infrared radiation also affecting it is there. Second example for such a type of energy, conventional energy, that is a non-renewable source of energy, thermal power plants. In thermal power plants, the heat energy produced by burning fossil fuels like coal, petroleum or natural gas is used to heat water and change into steam which rotates the turbines of generators to produce electricity. What is the meaning? One schematic diagram I have given. Take care children, here in this schematic diagram, the black color is a coal, it has to burn. This is a boiler full of water. So for boiling water, the water has to boil from burning of coal. Steam is producing. The steam which is coming out from the boiled water having high pressure which is rotate the turbine. The turbine which is connected to the generator to generate the electricity. Okay. So the burning coal producing heat to water boiling, high pressure steam is coming out from outlet pipe which is connected to the turbine which is rotated, so which is connected to the generator, electricity generation. So here some energy conservation also takes place. Energy conservation. So how the energy conservation? What is mean by energy conservation? Law of energy conservation already I have studied it when you was in the 9th class. Energy neither be created nor be destroyed. it can transform one form of energy into another form of energy. Here what type of energy conservation? Burning of coal, which is a chemical energy. Boiling water is a heat is producing, chemical convert to heat energy, which is rotating the turbine, mechanical, and electrical energy generating. Chemical energy, heat energy, then mechanical energy as well as electrical energy. Third example for conventional source of energy is hydro power plants. In your locality, so many hydro power plants are available. In Karnataka, so many places hydro power plants are there. Small also there, some big plants also available because the availability of water is more in these areas. In hydro power plants, the water from the rivers are stored by constructing dams. The water from the dam flows down through the pipes and rotate the turbine of generators to produce electricity. Actually, the turbine has to rotate, which is connected to the generator. How we have to rotate the turbine? The person cannot sit and rotate the turbine, it is impossible. So, with the help of thermal power plant, the pressure steam rotated the turbine, but hydro power plant, flowing water, moving water will rotate the turbine. Here one diagram it is given, you can see children. So this is a dam, water reservoir. During the rainy, from the rivers, some other water from mountain, hill, everything storage will be here. When the gate will be open, so the water will be releasing, moving water, which is rotate the turbine, which is connected to the generator, so producing the electricity. Then with the help of transformer and power transmission cables, we are transmitting to several areas are there. Okay, here also energy conservation it is there. So water stored in a dam, potential energy, convert into moving water, kinetic energy, rotate the turbine, mechanical energy, electricity generated, it is a electrical energy. Potential, convert to kinetic, convert to mechanical, converted into electrical energy. Advantages of hydropower plant. One is flowing water is a renewable source of energy. The electricity produced does not cause any pollution. The water stored in a dam can also be used to control floods and for irrigation. So sometimes no dams are there, no collection of water in the particular place it is there. So automatically flood will be takes place. The people, those who are staying near the area will affect more. So that is one of the important advantages. Then what are the disadvantages from the power plant? The initial cost is very high. The large area of land gets submerged, collapsing, and decomposition of vegetation produces methane gas, which is a greenhouse gas. It causes displacement of people from large areas of land. Next one, under the same source of energy, biomass energy, which is very important. Every villages almost the biogas, which is the biogas plant, it is available to producing the energy is there, biomass energy. What is biomass energy? The waste materials and the dead parts of living things are called biomass. The waste materials and dead parts of living things are called biomass. Example, wood, animal dung, vegetable waste, agricultural waste, sewage, etc. Biomass is decomposed by anaerobic microorganisms to produce biogas. Biogas is a mixture of gases containing methane, carbon dioxide, hydrogen and hydrogen sulfide. So after getting biogas, lot of gases containing in it. Methane is a large percentage is there, around 70 to 75 percentages are available. Carbon dioxide and hydrogen sulfide also available along with the methane in biogas. Now how biogas plant is working to producing usable form of fuel we are getting from that one. The biogas plant has a large area, 1 acre, 1 hectare, 1 acre, 1 hectare, 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 underground tank made up of bricks and cement. Okay, now I'll show the diagram, then afterwards I'll come back here. You can see this is schematic diagram for dome type of biogas plant which is given in the syllabus, children. So this is a biogas plant. You can see the shape is a dome here. Where they are constructing, the biogas plant has a large, it's a very big underground tank made up of bricks and cement. Okay, like our building how we are constructing, like that underground we have to construct it is there. Okay, the lower part is called digester. The lower part here which is there, this one down it is there. This is a digester. Okay, here only the anaerobic microorganism has to produce it is there. So this is like our stomach digester it is there. So the lower part is a digester and the upper part has a dome. Here is a dome with a gas outlet. With a gas outlet. After producing the gas through the outlet pipe only we have to get it. One side of the tank above the ground. This is above the ground. This all below that one. Only this outlet and inlet, that outlet biogas. Okay, that is only will be visible for outside the ground will be there. So little dome also will come out. Okay. So now here you can see, children. So one side of the tank above the ground here is a mixing tank. This we are calling is a mixing tank it is a. And another side which is we are calling as a overflow tank. Left side it is a mixing tank. Right side which is available is called overflow tank is a. So now what we have to do, animal tank is plenty is available in villages. Okay, it is available, it is more. So animal tongue we have to mix with water which is we are calling as a slurry. Slurry of cattle dung and water mixed together and we have to send from this inlet pipe to digester. Through this pipe it is coming here. Through this pipe it is coming digester. Here it is coming is there. Here what will happen, in this digester the slurry is decomposed. The slurry will be reached inside the digester. It has to decompose by anaerobic microorganism in the absence of oxygen, and after few days, around 60 days, 60 plus days we have to take it, the biogas is producing. Okay, that is a very important. We are sending slurry from inlet tank. Inlet one small tank is there. From there we are sending to digester. We are sending to digester is there. Here few days, 30 days, 60 days according to the how much size of the constructing tank. After few days biogas is producing. Along with the biogas mixing of methane, carbon dioxide, hydrogen and hydrogen sulfide. All together it is there. But biogas means we are using as a methane which will be producing 70% and above it is there. The gas is taken out. So whatever the biogas is producing, so that will become above the digester. Okay, near to dome it will become. Is a weightlessness, it will become up it is there. So through with the help of the outlet pipe, the biogas we can take it outside it is there, which can be used for heating and lighting purposes for our home. That will be usable form of one type of energy. So then waste slurry, the slurry which is left in digester, that will be remaining is there. The slurry which is left behind rich in nitrogen and phosphorus. Lot of nitrogen and phosphorus are there which can be used as a manure of crops. It automatically be pushed up into outlet tank it is there. From that outlet tank collection will be there. That collected the left slurry, it rich in nitrogen and phosphorus can be used for as a manure for cropping purpose it is there. Okay, children. So this is a fixed dome type biogas plant. Afterwards some of the modification is there. Floating dome. What happened? So it is a fixed. This is a fixed. It is a constructed with the help of bricks and cement. We cannot change any size and all things. So sometimes biogas is producing more are there, but availability space is not there. So for that one floating dome, that means it will be move. More biogas is entering means the dome automatically move up. The dome which is showing is here, that will be moving up. So storage of biogas will be more inside it is here. So such a way they are doing for floating dome type of biogas plant it is. Okay. The waste material we can use the vegetable waste, animal waste, especially in village we are using the cow dung we are using is there, mixing with water, preparing the celery, the mixing of water in the molten stage na, that we are calling as a celery. So we have to keep celery inside the digester in the absence of oxygen. Few days we have to keep it. So anaerobic fermentation, in the presence of anaerobic fermentation only this decomposition will be takes place there. So that biogas is producing it is there. So mainly methane is act as a fuel of biogas is there. Okay. So this is another one diagram, same thing. So here the main important part, the celery is decomposed. Why it is so decomposed? Because of formation of anaerobic microorganisms. Okay. So that is this diagram will be showing is same diagram, but the bacteria we are showing. Next one, wind energy. Wind energy. So in place of Karnataka, while traveling in the bus, you might be seen. So wherever the hill, especially Chitradurga and all, one of the place in Karnataka, so lot of wind farms are there, windmills are there, so to generate the electricity. Okay, what is wind energy? How to construct windmill? What is the advantage and disadvantages? We have to see. Now, what is wind energy? Wind energy is used in windmills, which converts the kinetic energy of wind into mechanical or electrical energy. So windmill, everybody might be seeing either diagram or directly also. In this diagram, it's shown one windmill it is. So windmill consists of many wings also there, 3 wings, 2 wings also it is available it is. Okay. So the heavy wind will be there wherever, there automatically wind is nothing but moving air. Moving air. So moving air producing the wind which is rotate the wings of the this one. Wings of the windmill it is. So the kinetic rotation will be there. So mechanical energy producing from the wind, kinetic energy. Kinetic energy of wind giving mechanical energy. So mechanical energy automatically inside that generator and everything will be there. So electrical energy will be producing it is. The kinetic energy of wind can be used to do mechanical work like lifting water from the wells or grinding grains in flour mills. It can also be used to rotate the turbines of generators to produce electricity. A single windmill produces only a small amount of electricity generation. So, large number of windmills in a large area are occupied together to produce more electricity in wind energy form. Is it clear, children? So, one windmill will produce very less amount of electrical energy. It is not sufficient to operate any sort of work in home. So, we need more amount of electrical energy so that we have to construct wind energy farms. Okay, so group of windmills, cluster of windmill is required it is here. That we'll see. So mainly all the windmills here also wind farms are there. So whenever the wind will be rotating, wind will be flowing, blowing wind, and wings are rotating, the kinetic energy convert to mechanical to electrical energy. So what are the advantages of windmill wind energy? It is a renewable source of energy. It does not cause pollution. The recurring cost is very less. Recurring cost is very less, but while constructing the one windmill and wind farm is very high economically will be there, high cost will be there. Disadvantages. The wind is not available at all times. Every time the high wind will not be there. It requires a large area of land to construct wind farm. A minimum wind speed 15 km per hour is required. The speed of the wind is 15 km per hour is required. Then only the mechanical energy, the wings of windmill will be rotate. Mechanical energy will be converted to electrical energy. Okay, children. So all type of power plant having advantages also there, disadvantages also there. Now we are going to discuss the non-conventional sources of energy. It is one of the very important sources of energy which is required for us now. Once the fossil fuels going to exhaust like coal, petroleum as well as natural gas, we should depend upon only the non-conventional source of energy or renewable sources of energy. So under the non-conventional source of energy, we should discuss about solar energy, sea energy, geothermal energy as well as nuclear energy. We have to discuss it. So first of all, we are going to discuss about solar energy. Solar energy is the energy obtained from the sun in the form of heat and light. Everybody we knows it is not the new thing for you. While standing outside in front of sun, so you can feel, so it is visible, you can see everything around you. At the same time, within few seconds, few minutes, we will feel little bit warm in our body. The solar energy is a type of energy. From that we can obtain heat and light energy. The energy radiating from the sun. What energy is radiating from the sun? Both heat and light. The heat energy which is we are using in solar heating devices like solar cooker, solar water heater and solar furnaces. Solar cooker, solar water heater, solar furnaces, the heat energy we are using from the sun. The production of heat energy from the sun, mainly infrared radiation. Infrared radiation producing the heat energy. So that is only we have to use for this type of devices. The light energy is used to in solar cell to produce electricity. So here some of the diagram I have shown here. One solar cooker. So with the help of electricity, with the solar cell electricity, solar cell it is there, lot of solar panel here, electricity generating, so pumping out water from the well for field and all thing, solar water heater, in your home the electricity we can get it from solar panels. Your roof of your home should be made by solar panel. Then very easy to produce it. The solar energy is one of the ultimate sources of energy. Solar energy is the ultimate source of energy for all type of energy it is said. Okay. First we will see solar cooker. So I have taken is a box type solar cooker which is given in your syllabus. Box type solar cooker. Advantages are more. At the same time some disadvantages everywhere children in our daily life. One work we are doing means advantages also there, disadvantage, which is we are getting benefit as per we have to go. Solar cooker. A box type solar cooker has an insulated box painted black inside. Okay, insulated material, wood, thermocol, like that we have to take it. So inside is can be seen very clearly, the color is black. Black paint we have to do it. So it is converted by a glass plate which allows, you see here, see inside black color paint it is there. So above one lid will be there, it is made up of glass. So this box is covered by a glass plate which allows heat to enter inside. From the sunlight the heat will be enter, but whatever the heat producing inside the box, it cannot escape out. Okay. So it has a mirror to reflect more sunlight into a box. The food to be cooked kept inside the containers inside the box. It can produce the temperature of 100 degree to 140 degree Celsius. The boiling water 100 degree Celsius, but the temperature producing inside the box type solar cooker up to 140 degree Celsius. So the cook can be easily cooked. So such a sufficient temperature it is getting. See children, suppose sun is here, the sun radiation will be incident on this mirror, it will be reflect, certain angle only we have to keep it. The reflecting sun radiation trapping through the glass sheet which is covered the box type, then it will be allowed to pass through inside. The whole material, cooking material which is we are keeping, it is getting heat up. Then again heat energy producing inside the box. The important characteristics of this glass sheet is it allowed to enter the heat inside, but whatever the heat produced inside the box, it cannot escape out. Okay, so like greenhouse effect, the glass sheet is very important. So to increasing the temperature inside of the solar cooker. So one video I am showing here how to prepare or how to construct a solar cooker.
Solar cooker. A solar cooker is a device that is used to cook food by utilizing the energy radiated by the sun. Here you can see how a solar cooker is made. You may require a wooden box having a thermocol lining, aluminium sheet, black paint, mirror, glass sheet, hinges, wooden lid for the box, and containers to cook food. Take a wooden box having thermocol lining from inside. Now make a box out of the aluminium sheet. Paint the inner side of the aluminium box black. Now fix a mirror to the lid and with the help of the hinges, fix the lid to the wooden box. Now cover the box with a glass sheet. The glass sheet helps in trapping the heat radiations. The mirror helps in concentrating light rays into the box. Now this solar cooker can be used to cook food. Paint the containers in which you wish to cook black from outside. Place these containers filled with food item inside the box. Now place the solar cooker in direct sunlight. Adjust the position of the plane mirror so that a strong beam of sunlight falls on the glass sheet. The rays coming from the sun pass through the glass sheet and are absorbed by the objects inside the cooker. The glass sheet does not allow the solar energy to flow out in the form of radiant heat. Gradually, more and more heat radiations get trapped and the food gets cooked. The range of temperature that can be attained in this type of cooker is 100 to 140 degrees Celsius.